We are going to start by watching a brain pop video. So open up your ears and watch carefully.
Hey everybody, we'll be starting the movie in a second. Moby's just fixing the camera. Hey, be careful not to beep so close to the camera, Moby. It's pretty expensive. Hey, I think you got it. Try zooming out. Whoa, way too far. Zoom back in. Yeah, good job, I guess. Dear Tim and Moby, what makes a gas or a liquid a liquid? From Reynolds. Well, gases and liquids are two of the three main states of matter. Right, solid matter is the third main state. Matter is anything that takes up space. It's the material that all the stuff in the universe is made of. All physical matter is composed of tiny particles called atoms. And these atoms behave differently depending on the temperature and pressure of their environment. Hey Moby, can you zoom in on this glass of water? As you can see, water is made up of tiny particles called molecules. Each water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. At room temperature and at normal atmospheric pressure, these molecules form a liquid. The particles within a liquid are packed pretty close together, but they're not arranged in any kind of rigid structure. In fact, they move around and slide past one another pretty regularly. Liquids have a fixed volume, but they don't have a fixed shape. If you put liquid in a glass, it'll take the shape of a glass. And if you put it in a water pistol, well, it'll be shaped like the inside of a water pistol. Hey. Alright, let's say we raise the temperature of the water. If we boil it, it'll change state and become a gas. Zoom in on that steam, Moby. When you increase the temperature of water, you're adding energy to it. The particles get excited. And when that happens, they start moving around a lot faster and get farther and farther away from one another. But the changes in state are only physical. The chemical structure stays the same. Those particles are still regular old water molecules, hydrogen and oxygen. Unlike liquids, gases don't have a fixed volume. They have a tendency to expand, which means they'll fill up any container that you put them in. Yeah, thanks a lot, Moby. Anyway, one more to go. Solids. You're probably already familiar with solid water. We call it ice. Zoom on in here, Moby. When you lower the temperature of water, you're removing energy. As a result, the particles don't move around so much. They're still made of hydrogen and oxygen, but now they're locked into a pretty rigid structure. Solids have a definite shape and a definite volume. Under normal conditions, they look pretty much the same, no matter what container you put them in. Anyway, those are the main states of matter, and they aren't just for water. All matter, from hydrogen to plutonium, can be a solid, liquid, or gas. There are actually a couple of other states of matter too, but they're not as well known. First, there's plasma, an electrically charged gas. Every star in the sky, including the sun, is made up of plasma. So is lightning, for that matter. And the fluorescent light bulbs in your classroom are actually filled with plasma too. Also, there are colloids, which are mixtures that contain 2 separate phases of matter. Butter, gelatin, and paint are all colloids. There's even a state called a Bose-Einstein condensate, named after physicists Satyendra Nath Bose and Albert Einstein. That particular state has to be created in a lab since it occurs at close to absolute zero, or about minus 273 degrees Celsius, the coldest possible temperature in the universe. Anyway, that's all we've got for states of matter. You can turn the camera off now, Moby. Hey, I can't see anything.
Okay, boys and girls. So, who could tell me what did y'all learn from the brain pop video we just watched? Tyler?
That solid, liquids, and gas has molecules, and they have atoms in them.
Okay, and how do the molecules of a gas look like? Lauren?
They're all over the place.
They're all over the place. Good job. And how do the molecules for a liquid look like? Aaron?
They're kind of like a solid, but when they're moving, one goes to this side, one goes to this side, and they slide by each other, and then they move again. So they just move all over the place because when water's in a container, it takes the place of its container. It doesn't have its own shape because if you just put water on the floor, it will be splattered all over the place. It wouldn't have its own shape like a solid would. Because if you had an ice cube, it would stay a square.
Good job. Okay, last but not least, how do the molecules of a solid look like? Without looking at the picture. Nathan?
When you freeze it, it stays under. It doesn't get up because it's stuck.
Okay, good point, but not quite there yet. So good job. Zaire? They stay together and they are packed together, aren't they? They're
But they're
squished
kind of
together.
spread apart a little bit.
Okay. Okay, guys, I want you to take out your science journals because we are going to make some observations. Yes? Okay, good job. So I should be walking around and seeing everyone turning to the next clean page of our science journal. I want you to write liquid, solid, and gas.
Miss Solis, what is that?
Liquid, solid, and Liquid.
Miss Solis, what do you write on the side?
Just on the side, that's right. Okay. We are going to predict what each item that's over there is. If it's a liquid, if it's a gas, or if it's a solid. So, as I walk to each table, I want you to quietly observe your cups.
Oh, I know there's ice cream. Go to eat it. I'm like, oh, don't. And
There should be no talking, friends. Voice level 0.
Miss Solis, did you ever learn out of basketball play? I'm in 7th grade.
Yes, Daniel? What's your question, friend? Thanks, friends, for being so quiet, especially Kaylee's table over there. Good job. Okay, guys, right now, I want you to observe the root beer and the ice cream and tell me in your own words what is a solid, what is a liquid, and what is the gas. Do not raise your hand, just write it down.
So we write down.
Yes, you write down what you think the ice cream is, what the root beer is, and what the gas is. Alex, your journal? Where's your journal, buddy? You don't have one? There should be no talking. Okay, so I want you to turn around and talk to your elbow partner. And talk about what is a solid, what is the gas, and what is the liquid. Okay, let's all come back together and discuss as a class what's going to be the liquid, what's going to be the gas, and what's going to be the solid. Let's see who can. Houston?
The root beer is a liquid and the ice cream is a solid.
Okay, and why do you think the root beer is the liquid? Good job. Okay, who can tell me what in this experiment is the solid? Tyler? The ice cream. And why is the ice cream the solid?
Because it holds its shape and it doesn't fall. It doesn't like take it doesn't like move like a when you like pour it out, it doesn't move like a liquid.
Good job, Tyler. Okay, last but not least, what is the gas? Because honestly, I do not see a cup with the gas in there. What can the gas be for this experiment? Grayson?
It would be because it has the little bits of foam.
Okay.
You mean bubbles? Yeah.
So the bubbles of the root beer, because the root beer is the liquid. Okay, class, so we are going to start. Hold on, do not do it just yet. We are going to pour the root beer onto our ice cream and observe what's happening. And I want you to write your observations down onto your science notebook, okay? So I'm going to count to 3, and we are going to pour the root beer onto our ice cream. 1, 2, 3. Okay, guys, so I want you to write down everything that's happening right now.
It looks like a melting red. You got it
Write down the observation. What is happening right now? What happened to the ice cream?
He would eat it. It looks like coffee. Is that wasn't me. It was a bubble. He poured it in. I think it melted.
One, two, three. Eyes on me.
1, 2, eyes on you.
Okay, what on earth just happened to our ice cream and our root beer? Xander? Our ice cream is dissolving because we added what to a what? Lauren? Which is a
Liquid.
solid to a liquid. Good job. Okay, guys. So I'm going to walk around and see your observations to see if they are correct. Good job, Kaylee. I'm writing everything you're saying. I'm going to walk around and pass out the food, and you can start eating. Voice level 1. Y'all are being too loud.
It looks like chocolate tastes like chocolate. Look at my God.
Okay, friends, so I want all of y'all to come join to the rug and surround the rug. So let's all stand in a big square. Stand up, stand up. We're not going to sit down.
This is going right here.
Okay, so let's all surround the rug. Okay. And I am going to ask y'all, and I'm going to ask for four volunteers to go inside the square and act like gas molecules. Go back. Okay. Zaire, Josh, Kaylee, and Lauren. Stand up though. Stand up. So I want y'all to act like gas molecules at this moment.
Don't touch each other.
Okay, stop and go back. Okay, guys, what just happened right now?
Go back where you were.
Aaron?
They all spread it apart. They all were just going this way, that way, this way, and that way.
Okay. Okay, and now I'm going to ask 6 friends to go inside the circle and act like solid molecules. Chloe, Emma, Tyler, Aaron, Kingston, Helen, and Bridget. You guys, there should be no talking right now. Okay, so what's happening right now? Emma? We are all squished together. Did someone hear that over there? Because I'm hearing some talking over there, and there should be no talking. Okay? Okay, Emma, so what's happening right now that y'all are acting as solid molecules?
We're all squished together. Right now we're squished together.
Okay, so everyone go back outside the square. Ryan and Alex, I want you to act like liquid molecules right now. Good job. Okay, so everyone outside of the room now. Good job, friends. Can someone please explain to me what's happened to the molecules like in the liquid? Tyler?
They were moving and then they were moving less than the gas, they were moving less faster than the gas, and they were going in like circles, and then they
Okay, good job, Tyler. All right, so I am going to read a book, so I want y'all to sit down right here. There should be no talking. Thank you. Kingston, over here. What is the world made of? It's the title, I'm not asking. What is the world made of? Have you ever seen anyone walk through a wall? Did you ever drink a glass of blocks?
No.
Have you ever played with a lemonade doll or put on milk for socks?
No.
He's putting milk in his socks because he's thinking that milk is a what? A solid, but it's a liquid. Imagine if he didn't have walls and blocks, dolls and socks, milk and lemonade, rocks and trees. All these things are made of matter. The air and the breeze that blows the leaves, water flowing in the creek. Everything on earth is made of matter. Lucky for us, it's easy to tell that not all matter is alike. So who in here can point out a solid at this very moment? Fatima? His hat, they're right here in the classroom. The board, good job. What about a liquid? Kaylee?
Her water.
Miss Mosby's water, good job. What about a gas? Maya? Ryan, over here, right now. Just stay back there. Right there, sit down. Yes, we are a solid. Well, we're a solid, but then there's liquids inside of us. We agree there. Next page. Matter comes in 3 states. It can be a solid, liquid, or gas. Walls and blocks and socks are solids. Milk and lemonade and water are liquids. The air you breathe is gas. So I want everyone to inhale. Exhale. One more time. That, students, was air, which air is a gas. Chloe?
Aren't you also doing carbon dioxide because it needs carbon dioxide?
Yep, that's air. Good job, that's gas. Some solids are hard and some are soft, but all solids hold their shape unless you do something to change them. A wooden block is hard. You can push it and pull it and squeeze it. If your baby brother pounds you with his they made a dinosaur.
Actually, no. Is it wait,
Liquids have no shape. You pour a glass of milk for your sister, and the milk takes on the shape of the glass. If she knocks it over, the milk spreads out on the tabletop. It flows over the edge like a waterfall. It drips and splatters on the floor. Milk is not round or square. It has no shape at all. And liquids can be thick like a milkshake or thin like water. They can feel slippery like cooking oil or sticky like maple syrup. But all liquids can be poured. And all liquids take on the shape of whatever they are in. Nathan, sit down. Gases have no shape either. Like air, most gases are invisible. You cannot see them, but you can feel them. I want you to hold your arms and spin. You can feel the air move against your skin. Air fills up space all around you. You feel that?
Yeah.
That, my friends, is gas. There's always gas in the classroom, gas in the school building, gas outside, gas at home. You don't.
Yeah, me too.
Moving on. All matter, everything on Earth is either solid, liquid, or gas. The water changes its state easily as it gets warmer or colder. But most things stay in one state or another. Solids stay solid, liquids stay liquid, gases stay gaseous.
Not true.
Moving on. And it's a good thing they do. Can you imagine a world where toys melt? Where the walls of your house turn into hazy gas? And animals just walk in and out as they please? A place where on cold days you have to swim through the air, and where everything you'll like to drink is hard as a block? What a crazy world it would be. Right here they show the animals just walking in through the house. A little girl floating in the air.
She's like this.
Because this means that there's no gas, so she's floating. And right here, this girl is drinking a toy block. Imagine if there wasn't liquids, then we would be drinking solids.
Or eating.
Done? Yeah. Okay, guys. So who can tell me another example of a liquid? Kaylee?
Does that have to be in the classroom or maybe outside the classroom?
Outside the classroom's fine.
The water.
Okay. An example of a solid? Tyler? Okay. Good job. Last but not least, an example of a gas. Helen?
Gas, it can be like smoke.
Smoke? Okay. Okay, guys, listen up. I'm going to send you back to the tables, and I'm going to pass out a worksheet. And this worksheet is going to tell me if you know what a solid, a liquid, or a gas is, okay? And I'm going to call you all by tables. No, this is going to be independent practice, okay? And I want the table helper to get the privacy folders for each table member. Okay, so table 1, go back to your desk, please. Table 3, go back to your desk. Table 2, go back to your desk. Table 5, go back to your desk. And table 4, go back to your desk.
She wants to get